This is David Hamaker for EECE 237. This is Project 5, or what I have with it. It is not fully working, but this is what I've got so far. Um, I tried making a whole bunch of registers activate. I know the key one here is definitely this measure start register. And I use that in my read function because it looks like if I start um, the read, then I wait until uh, the done bit turns on, and then I mask off the bottom values, because if you take a look at the read register, or the measure register, sorry. The measure register, yeah, I turn on this bit, I've turned on the force start, I've turned them on both, but either way, I wait till this 16-bit turns on, and then I mask off these bits, which will have my data. And what I do with that data is I stick it. Well, I do have this weighted value here, but honestly, to debug, I just stuck it into this volts measurement, and when I do that, I get a really weird thing. Let's see, I am going to flash it real quick. And I have my ESP32 here. I have it wired to pin 36. I have my photo resistor there and a 10K resistor there, and I'm measuring between the two. I have, the resistor to 3.3 volts, and then going to the resistor which goes down to ground, and I measure the node between them. And let's see, I take a look at my terminal here. Oh, let's start another one. Oh, this is EECE read. And no matter what, I always get the same value. Even when I shine my light on this or cover it up, I always get the same value no matter what I do, even with these other registers here. I take a look at the control register. I've completely left it out and used the defaults. I've messed around with the cycle. I've messed with the attenuation register. I've cleared it all out. I've set just the first two bits for since I'm using ADC 0, that would just be the first two bits activated to 1-1, so I can read 12 bits. But it's, no matter what I do, I always get the same result. I mean, and this is the raw read here. I stuck this in to debug the volts here. Normally I would get rid of this line and stick it into the weighted average here, and just to make sure that would work, I ended up I wouldn't say cheating, but I used Arduino. Let's see. So here's my code in the Arduino interface, and using all of their libraries, mostly to test just the weighted amount and to see if I could get an actual analog read. I have a function that converts the raw data into volts. It's actually millivolts. And then I have the little setup there. And let's see, yep, there's the function to set up an analog read. And here's my weighted function. And I send that average into the print value. So this is what I end up having here. And if I shine my light, what that'll do is, shine it right there, it will increase, it will actually decrease the resistance on the photo gate, which means the voltage will drop down there. And when I turn off my light, it slowly but surely starts to go back up. And that is, again, because it is that weighted average. If I take out the average and just say volts and put the exact read in there and flash it over, there we go, connecting. And look at my serial monitor. Now when I shine the light on it, it jumps down very, very quickly. It's a very unstable signal. I'll cover it up, and yep, the resistance goes up, so it holds the voltage higher at the midpoint. And yeah, it's a lot more jumpy, so I can see how this averaging would be very useful if you wanted to make more stable measurements.